Hello everyone, this is Dean, and today I will be making a video on the geometry review submission. So the first problem is on chapter 6, section 1, and this section is about angles of polygons. So what I'll be doing is I'll be drawing the problem and we'll be solving it from there. So we can already tell that this is a parallelogram. It has 4 sides. We're going to be naming the points. This one is S, this will be T, this will be R, and this will be U. Now I'm going to be naming these points and giving them a number. As you can see, we can already tell that this point and this point, points S and U, they are equal. They both say 11x plus 4. And points R and T, they also equal because they say 5x. So a rule on parallelograms are that the opposite points always equal. So even if you draw a random parallelogram, let's say, for example, like this shape right here, it's always gonna equal these two and these two because they're opposite angles. So the point of this question is to find x. The first thing we can do is, we know that this is the parallelogram, and we know that all of these points added up is equal to 360. So we can do point R plus point S plus point T plus point U, and you will get 360, and if you solve it like that, you can find what x is. So we can set it up now. Theoretically, you wouldn't even need U or T, because as long as you have one of these, you will be able to just double this and it will all work out. So x would equal 11. And that is how you do the problem. And you could plug in x into these equations and you'll be able to find the actual value of these points. So for example, if I wanted to find what U or S is, I would just plug in 11 times 11, which would equal 121 plus 4, that would be 125, and that is what U equals. The next problem, so the next question comes from chapter 8, section 6, and this section is about the law of sines and the law of cosines. So we already have a triangle over here, and I'm just going to be naming these points just so you make it a little bit easier to identify. And I'll be giving the sides a value. So the question states, find the measure of L round to the nearest degree. Okay, so the first thing you can do is identify whether you can use the law of cosines or the law of sines. And we can see that we have to use the law of cosines. So I'm just going to be setting it up without actually putting the values in. So now this is basically the law of cosines, and we can plug in the numbers and we can find what L equals. So if you guys are kind of confused, which I definitely was at the beginning, I'm just going to be identifying these variables. So L equals 24, N equals 27, and N equals 5. And pretty much this is like a trick. So the capital M and the opposite side is always going to be the lowercase. So obviously the 27 is going to be the lowercase n, and 5 is going to be a lowercase n, and 24 is going to be a lowercase l because it's the opposite side. Now that we have the equation here, we can simplify. Now that we have this, we can simplify it even further. And in order to move the cosine to the other side, we can always use this formula. And you can use your calculator to solve this part faster. And you will get approximately 48.8 as L. And that is how you solve this problem, by using law of cosines. So the last problem we'll be working on is in chapter 10, section 4, and this section is about inscribed angles. So I have the problem drawn over here, and we are given R and S, and the point of this problem is to find the measure of R. So because R and S both intercept TQ, we can automatically assume that R is always going to equal S. So we can already put in the formula, as in 12x minus 13 equals 9x plus 2. So when we solve this problem, we will get x equals 5. And that is the value of x. And again, we were able to do this because inscribed angles, which tell us that R and S both intercept TQ over here, arc TQ. So when we have x equals 5, that's not the end of our problem. It is to find R. So we can just plug in 12 times 5 minus 13, which you'll get as 60 minus 13, or 47. that is all for this review, and thank you for watching.